All right, so example 3 is just some more practice. We've got a 3 by 3 matrix and another 3 by 3 matrix, and we're going to compute the product A times B. All right, so A times B, we're going to compute that product. So in that last example, I wrote everything out. I wrote out each element, all the multiplication so you could see it. Now, in general, I don't do that. I do a lot of it in my head. So, but it does help, I think, to highlight the rows and columns, right? So that you don't get messed up. But what I would normally do is I would say, okay, 3 times 1 is 3. 2 times 2 is 4. Add that to the 3, so that's 7. And then I'm going to subtract 1, so that becomes a 6. So, oops. So I do a lot of in reality, I'll do this arithmetic in my head. So I get 6 for the first element rather than writing everything all out. So it's fine if you don't want to write everything all out. And then let's go on to the next element. So I'm going to erase that, and let's highlight the second row. So when I multiply the first row times the second column, I'm going to get the element in the first row, second column. So I'm going to take 3 times 3, which is 9, plus 8, which is 17, and then plus 3, wait, let's see, 9 plus 8 is 17, plus 2, sorry, so plus 2 is 19. So this element is 19. All right. Now let's go to the next column. So we're going to now take the first row times the third column, so which will give us the element in the first row, third column. All right. So we have 3 times 4 is 12, plus 2 is 14, plus 3 is 17. Okay, so this element, is 17. So 17. Okay, so now I've got my first row complete. Now I can move on to the second row. So I'm going to multiply the second row times the first column. And so what do we got? We got -1 plus 4, that's a 3, minus 3 is 0. Okay, so we have a 0 right there. And then we move on to the second column. So we're in second row, second column. -3 plus 8 is 5, plus 6 is 11. Oof. Remember to switch my pen. 11. All right. Lots of switching pens here. Let's move on to the second row, third column. All right. So let's see. -4 plus 2 is -2, plus 9 is 7. All right. Let's move on to the third row. All right, so now we're going to do the third row, first column. So that's 3 times 1 is 3, and then plus 8, that gives me 11, minus 1 is 10. All right, you'll get the hang of it, just practice. Now we're going to go on to the third row, second column. Whoops, I thought I had the highlighter. Second column. All right, so then we've got 3 times 3 is 9. 9 plus 16, that would be 25. Plus 2 is 27. All right, one more element to go. We're going to do third row, third column. All right, so we have 3 times 4 is 12. Plus 4 is 16. Plus 3 is 19. So 19. And there you go. There is the product of A and B. Now, before I go on to the next example, I just want to mention a few things here. Now, I've already mentioned that there's no commutative law for multiplication, but there is an associative law. So if you have 3 matrices that you're trying to multiply together, you can multiply the first 2 and then take it times the third, Or you could take the last two, multiply those two, and then multiply by the first. You just can't switch them around. You can't if you're multiplying A times B times C, you have to multiply in that order. You cannot switch the order around, but you can switch the grouping around. So that's the associative law. There's also a distributive law. So if you have a matrix times the sum of two matrices, you could add the two matrices, B and C, and then multiply by A. Or you could take the matrix A times matrix B and add matrix A times matrix C. Okay, so there's a distributive law for matrices. There's just no commutative law. All right. And then there's also something called the identity matrix. Now, the identity matrix is like the one in the land of matrices. We have the number 1 in real numbers, and the number 1 is considered the multiplicative identity, which means that when you multiply something times 1, you always get that same something back. It doesn't change the value. And the same with the identity matrix. It's a matrix that we can multiply by any other matrix, as long as the sizes are the same. And so this is in the case of an n by n identity matrix. So then it's like the one. It's the multiplicative identity for matrices. Okay, so hopefully you'll see in a moment. Well, actually, you probably see in the next lecture, in the next section, why the multiplicative identity is important. But it's just letting you know that there is such a thing. All right, I'll meet you in the next video for the final example.